recorder. So everything is going to be screen recorded. What you see on the projector is going to be recorded along with my voice, and it will be posted on YouTube. It's actually being streamed to YouTube as we speak. So there's a slight delay. Somebody can actually watch this lecture with a 2 or 3 minute delay compared to the actual real time. All right, so this class is, well, I don't really see a lot of familiar faces, so I'm going to use Canvas for this class. How many people have not used Canvas? Okay, so you have to go to this particular website. I'm going to write it down here. You might want to write it on a piece of paper or take a picture on the screen. So mouse pad. And it starts in another desktop. Okay, so the website that I'm using here is canvas.losrios.edu. It's not the actual URL, but it will bring you to the correct website. Okay, so I'm using Canvas, and this is the Los Rios Community College District, and this is the URL, or one of the URLs you can use to get to Canvas. So switching back to the browser. So what you need to do, this is the actual URL, lrccd.instructure.com. Okay, but if you use the other one, it will bring you to this one. So either way it will work. This is cisp310. I think the section number is 20331. And I might have updated the wrong one. Let me double check. No, this is 129. This is 12429. Okay, so I think I got the right one here. There we go. So once you sign into Canvas, you can go to the class website. So all the notes, all the homework, they're all on Canvas for this class. There are no textbooks for you to buy. Okay. Well, it's good and bad. It's good that you don't have to spend any money, but the downside is you're stuck with my notes, and I'm not rich enough to have an editor to go through all my stuff to fix the mistakes. So if you guys spot anything that I should fix, just let me know and I'll fix the mistakes. But I'm not making any money out of this either, other than my usual salary. So okay, so the first thing I'm going to go over is going to be the syllabus. So when you go to the website, your view is going to be different. This is the professor or instructor view. But you would see under modules, you will see a syllabus. So the first part of the syllabus is nothing really exciting. It's just a whole bunch of stuff that is copied and pasted from the college schedule. So this is CISP3. Oh, did I use the wrong one? No, this is the right one. It's just the prerequisite is CISP 360 or 480. So I'm hoping that all of you know how to program in C++ to a certain point. Okay, so we don't use object-oriented programming in this class. So if you don't understand, what is a superclass, it's not a big deal in this class. Okay, but you have to know what is an array, what is a pointer, how to dereference, how to take the address of, what is a local variable as opposed to a global variable. You have to know what is recursion, at least in terms of concepts. Okay, so I'm not going to ask you guys to write recursive algorithms in this class, but you still have to understand how recursion is different from something that does not have recursion. Okay, so that's the kind of stuff that you should have gotten out of your CISP 360. For anyone who has exposure to Java only but not C++, my recommendation is to take C++. Okay, because Java is not sufficient as a prerequisite for this class. Because, well, the reason is simple. Java doesn't have pointers. And pointers and the mechanism of dereferencing and taking the address of is really important in this class. So continuing on, the final exam of this class is going to be on the 13th, which is in December, which is a Wednesday. The time is from 10:15 to 12:15. So it's a 2-hour final exam time slot. Somebody else might want to double check to make sure that this is the correct time slot. but I'm fairly sure it is correct. These are what we call SLOs, or Student Learning Outcomes. If you are taking a class and the professor does not talk about the SLOs, well, they're supposed to. This is supposed to be mandatory now that we have to include the SLO in the syllabus so that you can double check and see whether you have learned all of these things that you are supposed to have learned in this class at the end of the semester. Okay, so right now, we are not going to go over these. And then after that is the tentative schedule of this class. The ordering, don't worry about the ordering because I have changed the ordering quite a bit already. But these are the topics and approximately how much time is allocated to each topic. And then at the end of all of this, there's also the rest of the syllabus. This portion here, these are all specific to cisp310. But when you get down to the bottom here, the rest of the syllabus, I'll open it up in a new tab. This is generic. This is generic to all of my classes. There are two versions. For those of you who like to print stuff out, you can print out from the PDF. And if you don't like PDFs, HTML works really well in the classroom or on a mobile device. Are there any questions at this point? Yep, go ahead.
Have you published the website yet?
The website?
On Canvas?
Yes. I'll write it on the whiteboard. So this is a quick way to get to it. It's canvas.losrios.edu. It is a link that will bring you to another URL, which is what I'm using on this tab here. So the actual link is lrccd.instructure.com, but the other one, the one that I have written on the whiteboard, will bring you there as well.
I'm on it, but it says that the page has not been published yet.
Oh.
Yeah.
Did you click on the lecture or the lab?
The lecture. Go to the lecture.
It just says they're both not published.
Yeah.
Huh. So the whole website is not published. Well, it says core status is published.
Click on the green publish button.
Oh, I think that's the other section.
This is lecture. It is section 1, 2, 4 to 9, I think.
I think we're like 1, 2, 5 something.
Oh, you're right. Okay. Okay.
Yeah, it's 203.
Got you.
Yeah.
I got confused. I confused myself. So I'm going to use this for now, and I'll mirror it to everything to the other class. Thank you for pointing it out. Okay, but the two classes are pretty much the same. They're the same class, same material. Okay. Sorry about that. Okay, so the course information is going to be wrong too. This is no, I got that part right, except so I got it all mixed up. Okay, but this part is still the same because these are all common to all of my classes. I'm not going to read out the entire thing, so you will probably have to read the rest of this once I fix the class website so that you can get into it. So this is about me. I'm Tak. My last name is Aoyang. It is an approximation of my Cantonese last name. So don't bother to pronounce it correctly because English doesn't have the correct sounds, so it doesn't really matter. Just call me Tak. It's good. My phone number is 484-8250. If I'm not in the office and you leave a message, the message will actually be sent to me by email using MP3. So it's kind of cool. This is my email address, and I'm located in number 3, door number 3, in office number 3 in Liberal Arts 133. And this is the last semester that we'll still be using these buildings, because all of these will be taken down, demolished at the beginning of the spring semester, so that we will start to build a new building to replace all of these older buildings. So it's kind of cool. My office hours are from 8 to 9 o'clock from Monday to Friday. So if you need to meet with me other than this time, send me an email, and usually I can meet with you briefly after the class as well. Okay, so at about 1:30-ish, we can meet at that time too. Presentation delivery methods. This is a face-to-face class, so I will be presenting the material in class for the most part, but it's also getting recorded. If you want to find the recording, you want to go to YouTube. So I'm going to use a incognito window, and so you go to YouTube, go to some profs, okay, and go to videos. And that will list all the recordings in a reversed chronological order for the most part. You can see this is the live one. If you click on it, it will be pretty funny because it is actually live. So it is delayed by, I would say, about 30 seconds or so. So you can see the recording inside the recording because it's actually live. And then that's going to update, to look the same, with a slight delay, and that will update again. Remember I said something about recursion?
Yeah.
Yep, exactly. And this is endless. This is a recursion that won't stop. But that's how you find it, okay? Some profs, SOMEPROFS is the name of the channel. All right, so that's YouTube. Getting back to the other desktop. Section number 6 is about REC, or regular effective contact. Actually, I mistyped here. Is regular effective contact, which basically just says is your professor keeping regular effective contact with you. This is a face-to-face class. It's pretty hard not to have regular effective contact. The only way for me not to have regular effective contact is not to have eye contact, so that I turn around and write on the whiteboard the entire time. And when you guys raise your hand or just verbally let me know I have a question, I completely ignore all of that. Then I won't have regular effective contact. So I have to work really hard not to have regular effective contact. Now, if this is an online class, okay, it is much easier not to have regular effective contact. Okay, there are classes where the instructor or the professor can click a button in Canvas, reset a course, and just walk away. So that you guys will be doing the homework, but they're all graded automatically. You'll be taking tests, but those are all graded automatically. So the professor doesn't have to do a single thing, doesn't have to interact with you at all. So this section of a syllabus is to address mostly online classes, but not so much face-to-face classes. How many people have taken an online class? What's your experience with online classes? Good? Hate it? Okay. I think it depends on the kind of class. Okay, so if you're taking a class where most of the material, kind of is self-explanatory, probably okay. If you're taking a class where it takes a lot of human interaction to explain something, may not be as easy, or may not be the same experience as a face-to-face. Any additional comments? No? Okay. All right. So time frame policy mostly applies to email and text messages. I have 24 hours as a turnaround time, except for weekends, which is going to be about 48 hours. Okay. Sorry?
You sneezed.
Oh, okay. And I'll just say, be well. I went to Walgreens, the drugstore, and I think as a corporate policy, whoever is working there, after you pay for your merchandise, they all have to say, be well.
Well, it's not job security.
Huh?
It's not job security if you're well.
All right, so college schedule holidays and breaks are exception to this rule, so do not expect the 48-hour turnaround time around Thanksgiving time. Okay. Etiquette policy. The bottom line is I just want to make sure that when we do communication, online or otherwise, We just want to make sure that the classroom or the online forum does not create a hostile environment to anyone in class. So that's usually just common sense. Any content that creates a hostile environment or can reasonably lead to interpretations of harassment or discrimination would not be allowed. So that would include these examples. Cyberbullying is just bullying and is also not tolerated. Spamming is not tolerated because it's a form of denial of service. And on top of that, content that is offensive would also not be tolerated. So just common sense, if you have any specific questions about this, you can email me about it or just come to my office hour and we can talk about it. You guys are all here, first day of class or orientation, so you are not going to be dropped because of being absent on the first day of class. Unless you're one of those people who are watching YouTube right now. Remember, it's getting streamed, so somebody can technically be watching this online. And those people, if they're not here when I take roll, well, since I got the wrong roll sheet, I can't do that. Accommodations for disabled people. If you need accommodations, you don't need to let me know, but you do need to contact our DSPS office. Here's the phone number for more information. Excessive absences would be 6% or more. So if you don't want to read all of this stuff here, in a regular typical class like this, the third unexcused absence is going to be excessive. So you have 2 unexcused absences that you can use throughout the entire semester. But the third one is going to be excessive. And excessive absence means that person can be dropped from the class. Okay. Certain absences can be excused, but those are limited to health issues of the student himself or herself. That is, there's a doctor's note or some other documentation to bring back and show me that yes, I was sick or I was hospitalized, or this physician told me that I cannot go to school because I was, I can infect other students. Okay, but I need some form of paperwork to support it. And there's a whole list of unexcused absences: religious holidays, family occasions, job interviews, and so on and so forth. So if you need to go with your family on a trip or something, use up one of those 2 days. You have 2 days of unexcused absences that you can use throughout the semester. Late policy is easy to remember. There's no late policy. Cannot turn in anything late for credit. Which basically means you just have to plan for it. Right? Okay. Unless it is, sickness that is, that is verifiable. So in that case, those cases can get an extension. Section 12 talks about, basically what most people refer to as cheating. So cheating, in my definition, is a little bit different, can be a little bit different from your other classes. It's basically whenever a person is involved in a process, in activities that will lead to the demonstration of a possession of a level of competency, knowledge, or skill beyond the level of a particular student. I don't care how it is done, okay? But if somebody was able to demonstrate a level of competency, knowledge, or skill beyond the actual level of that person, and it is done intentionally, it is considered dishonesty in this class. Are there any questions about that? So if it's done telepathically, still counts. So the other way to look at this, in a more positive way, is to look at academic integrity. So the grade of a particular assessment of a particular person reflects the academic performance of the student and only of that student at the approved scheduled time of the assessment following all the rules of the assessment, and using only resources allowed by the instructor. Is that okay? The only people I cannot catch easily will be Time Lords. That may be a little bit of a problem there. So if Doctor Who decides to travel into the future, look at the review of the questions of an exam and then go back to the past and take the exam, there's really not much I can do about it. But we know that there are only one Time Lord left by the end of season 13. As long as that doctor as long as that Time Lord is not in this class, I don't have that much to worry about.
Well, they did go into parallel dimensions, though, so.
That's true.
But I don't think we have to worry about it.
Yeah, but I really miss Missy, so I hope they bring her back at some time. So the litmus test of academic integrity is if I suspect anything, I can ask a particular person to take an alternative test. Okay, if the result of the alternative test is very different from the result of the suspected test, then I have reason of saying, well, especially if the performance of the alternative test is much lower than the original test, then I have a case and I will bring up to the dean. Okay, there are occasions where maybe it can be explained, but this is how I would test if I need to find out whether somebody is honest or not. I do want to explain the importance of academic honesty and why I put some emphasis on it. Because if I allow people to cheat and get away with it, it impacts everybody. And that's the bottom line. Okay, it's not just the people who do the act who will find out at work that, oh, I'm getting assigned some job that I don't know how to do because I didn't actually study. Okay, and I can tell you some stories about that. This one is about a relative. Okay, it's not my actual relative, but it's on my wife's side, who decided he went to Berkeley, and at Berkeley is highly competitive. Okay, so they have these groups or rings of students who would take exam and tests for each other. If you're really good at math, you will take the math tests for everybody in your group. If you're really good at English writing, you will take all the exams for the entire group. Okay, so this person graduated from Berkeley and got a pretty good GPA out of it. When he was hired by a particular employer, a famous employer in aerospace and whatnot, he was assigned not only engineering kind of job but also documentation. But he's really good at math, but not so much at writing. So he felt all the pressure, when he's on his job, and it's not good, okay? Because he's in a position that he really maybe he should not be in the first place. But the bottom line is, UCs and CSUs can decide and say, hey, ARC, students coming from your school, even if they have an A or B, they do not seem to know enough about the subject area, and they can just go like, psh, we're not going to accept transfer students from AR anymore. So that impacts everybody. The majority of people are honest, but the few bad apples can give AR a bad reputation, and that impacts everybody. Section 13 kind of relates to Section 12. You have rights, okay, if you are wrongfully accused of anything. This guide, this document will tell you what to do, okay, how to file a grievance, how do you complain about it, who to contact, which office on campus will handle this, okay? So this is actually for your benefit, okay, your rights and your responsibility. Classroom behavior expectation, not really a whole lot to talk about except for the usual stuff. I just want to make sure that the classroom remains as an effective place for learning and teaching. And the most common problems that I get are chatting. It's usually because a particular person did not understand something that I said and decide to ask the person next to that person for clarification. So it's actually related to the class, but it does cause a disturbance in the force. No, in the class. I'm just checking. So if you have a question, like you didn't quite catch what I said, or you think, oh, he might have spoken it wrong, just raise your hand, let me know. It's no big deal. We'll just go ahead and I'll answer those questions. The classrooms, oh, I guess they took that sign away. No, it's right there, back there. So no food, no drink, no phones, and no kids. I don't really understand what prompted the last one, no kids. I guess, in some classes, people bring their kids because they cannot arrange daycare easily. I don't know, maybe. But basically, in this classroom, I don't want any food. If you need to drink plain water, it's okay, because you don't have a computer other than your own in front of you. Okay, if you spill water on your own computer, well, that's on you. But I don't want anything that is sweet or sticky or has color. Okay, so plain water is cool. If you just have caffeinated water, I think that's okay too. You can actually dissolve caffeine in just plain water, and it's just caffeinated water. Probably doesn't taste very good. Go to the chemistry department, ask somebody to order like 2 kilograms of concentrated caffeine. Sorry? Caffeine.
Comes in a white brick.
Yep. Okay, well, on that topic, somebody smuggled, I think, 13 pounds of crack cocaine using a drone.
Oh, yeah.
Yep, got caught. Okay, but that's the way. Sorry.
They put a little Amazon sticker on it.
I'm about to say, yeah. That's what I would have done.
So border control, now needs to have their own, drone killers, drones that kill other drones. Yeah, I don't think the wall is going to help in this case. Yeah, digging drones, tunneling drones. Oh, boring drones from Elon Musk. We can bore all the way down and back up again. Okay, so there's that. How to attend lectures. I'll just summarize. Okay, this is kind of long. I just want to summarize. I do record my lectures as long as I remember to bring my gear and remember to turn on the recording button. So I better double check now, because I don't remember whether I clicked that button or not. Okay, I did. Because a lot of times I would fire up the application, do everything to prep for the whole thing, and then forget to click the button to start when it's time to start. So from time to time, you might want to remind me to check. Okay, just to make sure that I am, in streaming. So given that, it also means that, if I use a lot of examples on the projector, you don't need to, be very busy writing down everything. Okay, so focus on what I'm talking, focus on the concept, focus on asking questions. Okay, if you don't understand a particular topic or a particular concept that I'm illustrating, slow me down, ask me questions, stop me. Okay, but don't use all your effort just trying to copy everything down. I don't have a problem if you want to use your cell phone and snap a picture of the screen, as long as I'm not in the picture. It's okay. Okay, so if you're planning to snap a picture, just let me know ahead of time. I'll step away and then you can take a picture. If I use anything on the whiteboard, you can snap a picture of the whiteboard as well. Okay. Usually I would ask before I erase anything on the whiteboard to make sure that nobody wants to retain that. If I forget, you can just kind of raise your hand or just say, okay, don't erase yet, I'm copying or I'm snapping a picture. Just let me know. Okay. The best way to prepare for this class is to read the material a little bit ahead of time. Now, obviously, the first class is not going to be possible because you don't have the material yet, because I made that mistake. So nobody can get into the class with the content just yet. Okay, this is a long section, how to succeed in this class. So I will summarize and just say that there are 3 things that I need you guys to demonstrate to get a good grade in this class. The first one is I will ask questions that will see whether you understand the concept or not. Now, how can I ask questions that will let you tell me or let me know whether you understand the concept or not? It's impossible, because I cannot get into your mind and look at how you think and look at how you connect the concepts of this class to concepts that you already understand, which is basically the basis of understanding. Okay? So short of a mind meld, I can't really tell. And since I'm not Vulcan, I cannot do a mind meld. Okay, so I cannot really test for understanding. So the next thing is I want you to be able to apply the concepts that you have understood. That I can test, right? Because I can give you a problem to solve, and the process of solving the problem can illustrate whether you understand the concepts or not, and also whether you can apply those concepts or not. So there are a lot of problem-solving type of questions in this class. There are no memorization questions whatsoever in the exams. It's open book, open notes. Anything that's either handwritten or printed goes. There's no quantity limitation other than how much weight your table can hold. If you bring so much stuff that the desk or table is going to collapse, I would have to ask you to stop. Is that okay? Yep.
Internet still no. Does internet work? No.
Internet? No.
No.
It has to be printed or handwritten. Which, yeah.
From the internet, like printed from it.
Yeah. And you can even take screenshots, okay? If there's a particular sample program that I have used in class that you think, oh, I want this to be available during the test, just freeze the screen, do a screenshot, print it out, bring it with you. Is that okay? All right. So section 16 is really long. It kind of explains what is understanding, what is problem solving, and also what the importance of trying to solve problems independently when you're working on homework assignments, and also when you're reading the text material for this class. Okay. In other words, this section is trying to explain when is a good time to ask for help. Okay. Is it after a minute of trying, 5 minutes, 30 minutes, a day, a week? How do you decide when is a good time to ask somebody else for help? So that's the question. And the answer is somewhere here, okay? And section 17 talks about grading, standard, how do you get a letter grade at the end of the semester. So we have A, B, C, D, F, and I apply these to grading all the homework assignments as well as all the exams. So when you look at A, B, C, D, F, the short descriptions, you should know these already, right? An A means excellent work, a B means good, a C means satisfactory/fair, a D is a low pass, and an F is a fail, okay? But how does that apply to a particular answer when I am giving you a score? An answer that deserves an A is a perfect answer. It cannot be any better, okay? It answers everything correctly. It shows complete understanding of the material and the ability to apply the knowledge. Perfect execution, okay? No errors, no excuse for me to take away any points. A B is a good answer, but with some minor or few mistakes or omissions. It shows understanding of the material, shows the ability to apply the knowledge. Commendable, but less than perfect execution. So maybe a silly mistake somewhere, a little omission somewhere, but otherwise it's still a good answer. A C is an answer with major or many mistakes or omissions. It still shows sufficient but incomplete understanding of the material and the ability to apply knowledge. A D is an answer that does not show sufficient understanding of the material. And then F is no answer, nothing turned in, or the answer does not show me anything at all. Not even just insufficient, it doesn't show any understanding of what I'm testing. So these are kind of abstract, so I have these other examples. I'm not going to read these, but I apply ABCDF to job evaluation. What kind of employee would get an A, in the job evaluation, and also product evaluation, which we all know, right? Even if you have never been employed, never been evaluated for job performance, you have bought stuff from Amazon, and you have read reviews of products on Amazon. So I'm equating what is a 5-star product to an A, what is a 4-star product to a B, and so on, because we all understand the star systems. How many people have not ordered anything from Amazon or any online store that has online reviews? No one. Great. So now we all understand, how I apply these standards. So the GPA centers of these particular grades would be 4, 3, 2, 1, and 0. I don't have to explain that. So this is the percentage range to get that grade at the end of the semester. If somebody accumulates at least 87.5% of all possible points at the end of the semester, that person is going to get an A. If a particular person gets somewhere between 62.5% and 87.5%, that's a B. A C starts at 37.5%. A D starts at 12.5%. And as you can probably imagine, very few people get an F in this class, in any of my classes, because an F means less than 12.5% of all possible points. Are there any questions about how I assign letter grades based on your score at the end of a semester? Questions? Yep.
Give us an example of like something that you would be like a B answer, an A answer, like. So if you say something minor, like say C++, we forget a semicolon, would that be still an A, or would that be a B?
It depends on what I'm really testing in that question. If I'm testing the understanding of local variables and recursion, and it's fairly complex, then I will look at the semicolon and go like, nah, that's not even important. So without the semicolon, that person will still get an A. Now, if the answer is missing a declaration of a local variable, that might bump to a B, because that is actually important, because I don't know, is this a global or is it local? If it's global, it is not recursion, or the answer is incorrect in that case. So there are certain things that carry more weights than others. Is that answering your question?
Yes.
It's kind of fuzzy. I know it's kind of fuzzy, but I would designate certain concepts that are particularly important. So typically the way I grade a single question is I would use a rubric system. There are multiple rows in the rubric, and then along each row would be the ABCDF. So if I have a particular row for syntax, then you might lose a point because of the semicolon. But if I only have rows, that talks about the logic of the subroutine and the concept of local variables and parameters, and syntax is not a particular row, then you won't get any points deducted. Is that okay? All right. To get these points, you will have homework assignments. Homework assignments only make up 20% of your grade. You will have exams. There are 3 exams. The first quote-unquote midterm is at about 1/3 through the semester. It carries 20% of your grade. The second one is also 20%, and that's about 2/3 through the semester. And the last one, the final exam, carries 40% of your grade, and that's one is comprehensive, but it has a lot more weight to the end of the semester. In other words, I tend to ask new questions compared to what has been asked before. Yep.
I'm in the discrete database class that's right before this. Do you think that the test days are going to fall on the same days?
I usually try to stagger things, to make it easier for students who are taking both classes. Also make my job a little bit easier.
Okay.
Yep. You mean discrete structure?
Or yeah.
Yep. You said discrete database.
Okay.
Yep.
Gotcha.
I just want to make sure that's what you meant.
Yes.
Yep. Okay, so that's the end of the whole syllabus. Are there any questions about the syllabus? questions? Okay. So before we actually get into the content of this class, I do want to show you this. Some of you have seen this already because you're in the previous class. I want to show you this website. It is completely optional. You don't have to do this. I did it. I took the test, and I found it to be helpful. Okay, it's helpful in many ways, because it can tell you what you're really naturally good at, your knack, so to speak. It will give you suggestions of occupations, along with other things like how to have a successful life and so on and so forth. So it's entirely up to you whether to take the test or not, and I absolutely do not need to know the results. Okay, so there's no need to turn in your results and go like, oh, I'm INTP or I'm ESFJ and so on. It is entirely for your own benefits. Okay, how many people have taken a test like this before? Okay, some of you. What do you think? I mean, if you want to share, that's fine. If you don't, that's fine too. Do you find the test useful? Not useful? Meh. I find it fairly useful. I'll give you one example. Don't take it the wrong way. I'm not suggesting anything. I'm just showing you a historical fact that is related to this kind of test. Last year, one particular student was kind of having a hard time with this class in terms of the concepts and stuff like that. So this student would come to my office hour, really good approach, and ask questions, which is great. But despite doing that, the student still failed the class at the end of the semester. And the student was kind of upset at the end of the semester because, with all the effort, asking me questions during the office hour and studying and whatnot, still did not pass the class. And then a semester or 1 or 2 semesters later, I met the same student. And then she came to me and then she said, well, thank you, Dr. Tech. And obviously, the first thing I thought of is, oh yeah, I got this coming. But that wasn't it. Okay, she was actually thanking me for introducing the personality test concept, because she was tested with a certain personality type, and the suggested career choices are a few other things. Okay, but they're not in programming or computer science or software development. It's on something else. So after she failed cisp310, she went back and took the test again and then reflected on it a little bit more. And then she changed her major to something else. And she was very happy and satisfied with her choice. And she said, she told me that, well, if it's not for the test and failing cisp310, she would still be struggling along this path. But because of the test and because of failing cisp310, it forced her to reflect, and then she decided to make a change, and that change was really positive because she was really comfortable with her new direction, and it used her strength instead of not using her strength in that particular area. So it's just one single data point. I'm not asking, hey, you guys need to consider some alternatives. No, that's not what I'm talking about. I'm just telling you a story, and however you want to interpret the story is up to you. So that's done. Good. Well, I'm gonna fix this as soon as possible, but at this point, I'm gonna just use this. But since everything is recorded, you can still review what I have gone through in this class, because you can just watch the YouTube after the class. Okay, so the first thing, or the first slide, is this one. Okay, opening a new window. Everything that I type in this class and all of my classes from here on would look like this. Super duper boring. It's all text, okay, because I usually don't have time to kind of throw in pictures to spice things up a little bit. But they are all critical modules. There are 2 versions. You can look at the PDF version. If you want to print it out, the PDF is great for that purpose. Or if you want to look at, read the notes using a mobile device, the HTML version is really great for that too. If you have a mobile device, I recommend Firefox over Chrome. I found that Chrome sometimes doesn't render some of the mathematical stuff correctly, whereas Firefox does a pretty good job doing it. So just an observation here. So we are actually getting into the class now. Okay, this is the actual content of this class. So the first section here has to do with physical states. Why do you think we need to talk about physical states in computer science?
Without it, there's no software.
Sorry?
Without it, there's no software.
Without that, there's no hardware to run software.
That's-
Exactly.
yes.
I knew what you meant. Okay, very good. That's exactly the right answer. Okay, so we need to run software, run the programs on something that is physical. And this class connects what you know about programming, the abstract stuff, to the physical stuff. Okay, the transistors and whatnot. So that's why we need to talk about physical devices, because all the computers have to be implemented in some way in physical form. And these are the alternatives. The first one is electromechanical. I can tell you right away that there won't be any questions in the exams that will ask you questions about this. This is just a background information so that we are aware of the different ways of implementing computational hardware. Electromechanical devices are basically things that have motors or some kind of actuators that is mechanical. But it's also electrical in a way because the actuators run on electricity. A relay is kind of electromechanical. Motors are definitely electromechanical. So the bottom line is, at the end of World War II, German Enigma encryption machines receive a fourth wheel to scramble broadcast communication. This is a part of a movie. Okay, how many people have watched
Imitation Game.
Imitation Game? Okay, I really should, but I haven't watched it yet. How was it? Do you like the movie?
It was really good. It's
It was
like a
really
beautiful
good?
mind, but with computers.
Sorry?
It's like a beautiful mind with computers.
Okay.
Somewhat inaccurate in the method that they use to crack
It's
it.
alright.
Yeah. So it focuses more on the drama part and not so much on the computer science part.
It's just Oscar bait, and there's a lot of people saying how inaccurate a lot of the portrayals of people were, so it's whatever.
Yep.
It's Sherlock versus the Nazis, basically. So.
Well, otherwise, people won't be watching that movie at all.
Well,
The documentary
yeah.
about Alan Turing is much better.
Mm-hmm.
There's also a book called Imitating Turing, which is really good.
Okay. Yep. But basically, this is the beginning of electrical, or modern day computers. It's for deciphering communication that was encrypted. It was doable by hand originally before they introduced the fourth disk, because the number of combinations became unmanageable when you do it manually. Now, whether something is doable or whether it's practical, there are two different questions. Okay, because in terms of decoding military communication, if it's doable but it takes 3 days to do it, then it's useless. Because by the end, when you have cracked the encryption, the value of that communication or cracking the communication has already disappeared, because the event would have happened already. And then you say, oh yeah, according to the communication that we received 3 days ago, this was supposed to happen yesterday. Yes, we know it happened, right? So the bomb computer was devised to semi-automate the process. These are very slow machines because there's only the speed of updating electromechanical devices is only so much. There's only so fast. The response time can only be so fast. It cannot be faster than mechanically possible. So the next phase would be to use vacuum tubes. A vacuum tube is exactly what the name implies. It is a glass tube with a mostly vacuum inside. I use mostly here because there's no absolute vacuum, ever. It's theoretical, but even outer space is not entirely vacuum. But it's vacuum enough for this to happen. So the mechanism is not important. Okay, so you skip all of this stuff here. The mechanism is not important. The important point of vacuum tube computers is they're way faster than electromechanical computers. Okay, they're way faster. And the first computer, or one of the most famous computers using vacuum tubes, is the Colossus. It's also invented at the end of World War II, and it is designed to decipher messages using a different cipher. The two different ciphers, they were both used by Nazi German, but there's a difference. Did anyone study these cipher machines and sort of? Okay.
You're not referring to the Navy diplomatic Enigma, are you? Where it had a fifth wheel as opposed to four wheels?
That would still be an Enigma machine. This one is entirely different. This one was used only at the highest level by, the machine itself is huge. The encryption machine itself is huge. It's not like a typewriter. So this one is for top secret communication, not for your field communication. And as a result, the cipher is far more complex than an Enigma machine. So the deciphering also require a higher performance computer. And then we move on to transistors. Okay, so the first few paragraphs talk about the actual device itself. A semiconductor material is actually a non-conducting. Let me show you which sentence I'm reading here. I'm reading this part here. Now, you don't have to know the actual physics behind semiconductor material. That would have its own class, as a EE class or electrical engineering class at most UCs or CSUs. But it's kind of interesting. To me, this type of thing is actually interesting. They use silicon as a base material, and silicon by itself is not conducting. Okay, it doesn't conduct. It's only when you introduce quote-unquote impurities or doped material, then it will start to be able to conduct. Okay, so the actual mechanism of doing this is not the focus of this class. But what we do care about in this class is it makes things go faster again. So compared to vacuum tubes, transistors are much faster. They're much smaller, and then the energy requirement is much less as well. And guess what? We are still using transistor technology. Nah, no way. I mean, these watches are made out of chips, right? Chips, transistors, they're not the same thing. Well, sorry?
Microtransistors inside the integrated circuit.
Integrated circuit, exactly. So we are still using transistors, but the transistors are in integrated circuits, which means a single physical device can contain millions upon millions of transistors, as opposed to discrete transistors. When you hold on to one thing, that's one transistor. You hold on to the second thing, that's a different transistor. Now you hold on a chip, and it has millions of transistors on that one little chip. Okay, but it's still based on transistor technology. It's still based on semiconductor technology. Okay. Very good. So sometimes it really helps to kind of reflect on the history of computers, as opposed to the history of other things in life. Okay, I talk about this sometimes with my buddies, and we talk about how at the end of World War II, they have already invented the jet engine, right? And the Germans were able to deploy jet-based fighters for a very short amount of time, and they were proven to be superior to propeller planes. So you would probably imagine that, well, now that we are, let's say, 60, 70, almost 70 years from the end of World War II, jet engine technology has improved. How much has it improved? In other words, you compare the fastest fighter jet at the end of World War II to the fastest fighter jet today. How much faster are we talking about?
Several times faster.
A lot.
Let's call it 7 or 8 times. Okay, which is a push because no actual fighters can fly at Mach 3. That's the Blackbird or the Recon plane. So we call it Mach 3, and we say at the end of World War II they're capable of about half the speed of light sound already. It's a push, but we'll call it 7 or 8 times. Okay. when you look at artillery, how far can you shoot a shell and hit something accurately? Well, we have improved, right? And then you look at computers. I got more computation resources on my watch than an entire building in World War II. There's no comparison. Okay, now you can look at it in a different way. So let's say aviation technology never improved since the end of World War II, but computers continue to improve just like just like it is in history. Okay, would we still have drones today? Yeah, we might have biplane drones, but we'll still have drones. You turn it around and say, okay, what if aviation technology improved even more than what it did in history, but computer technology never improved whatsoever? Would we have drones? No, because 10 B-52s would not be enough to carry a single computer. So there's a drone, that has 50, B-52s. They're tethered by communication wires, and here's another, 20, B-52s just to generate the power for that computer. That's a drone right there. Do you see, how computation technology is different from almost all of the other technologies? Okay. I'm old, so I look at these things and go like, wow, that's a big change. But you guys are younger. You grew up with this stuff, and you don't appreciate, how things have progressed over the years. Yep.
What was there's that rule that guy came up with, is like every certain amount of time.
Moore's law.
That's it. Yeah.
Yeah.
And
Moore's
it's
law.
Pretty dead on.
It has been pretty dead on, and people thought that we would have hit a wall already, and we kept going.
I remember this. I was reading this. It's like an old episode of the Next Generation. They refer to computation power by their computers, and in the '90s when it came out, it was like a lot, but they surpassed that by far in like the late '90s already.
I have a story about that as well. Okay, so Moore's law itself, says the density of integrated circuits would double every 18 months. That's basically what it says. But it roughly equates to performance as well, because when transistors get smaller, they can switch faster. And when they can switch faster, performance improves, okay? So you can sort of equate it to performance increase as well, okay? Doubling every 18 months. My roommate back in the early 90s, okay, when I was over at UC Davis, had a call sign of submicron, in our online games. So he chose that name submicron because at the time, people thought that transistors smaller than a single micron would not be possible. They have hit the limit already, and they could not make transistors smaller than a single micron. A micron is a millionth of a meter. Pretty small. When you buy a new processor these days, the top of the line, Intel processor, what is the size of a transistor? What is the width of a transistor? 14, I think, nanometers?
The technology says 14, but they can be anywhere from very much smaller to much bigger.
Okay.
That they changed the nanometers to be kind of like a generational gap, not an actual size measurement.
So let's call it 14, okay?
Well,
so
back in the day when they had like 28 nanometer, that was legit.
Oh, okay, I
28
see.
nanometers back in the day. They changed it now.
Okay, but let's just say use 14 as a uniform number, or average, okay? 14 nanometers, how does that compare to a micron? Much smaller. How many nanometers do we have in a single micron? 1,000, okay? So when they thought in the early 90s that they could not make a transistor smaller than 1,000 nanometers, now we have transistors down to 14 nanometers. Less than a 50th of what we thought was not possible. And how many years have passed? The early 90s to 2017, 30 something years, less than 40 years. You might think, well, 40 years, well, that's a long time. Tech, you're old. Yes, I'm old, older than you are. most of you. But 40 years is not all that long. When you look at other technologies, a car 40 years ago compared to a car today, well, the cars have changed, okay? But when you look at internal combustion engines, they haven't really changed all that much in 40 years. But when you look at computers, when you look at what is inside the integrated circuits, that has changed a lot. Okay, so I just want to kind of point out these things because guess what? That trend is going. It is still going. Okay, so when you are my age, you will feel older than I currently feel old because technology would have moved even faster in the future. So you guys better get ready for that. The generational gap between you and your kids, you know, the next generation, is going to be more interesting because things are changing so much faster. 500 years ago, what is the generational gap? The handle of your farm equipment is curved. It used to be straight. Or the type of wood that you use for a handle has changed. I don't like the new material. It's not as good as the old one. It's not tactile anymore. And these days you look at, the kids are all, you're always using the cell phone, look at the screen. Well, the next generation is all going to be VR. It's going to be AR/VR, and I think a whole lot of people would prefer V versus AR because they just want to be immersed in a world that is not reality.
VR, you can sit down.
And you don't have to get out of the house anymore. Well, these days, for practical purposes, if you want to go grocery shopping, you have to get to a supermarket and stuff. You have Amazon.com, and they are getting to the point where they can deliver food and groceries. Yeah, but it's not inexpensive, but it will get there. You can count on it that it will be competitive in terms of cost effectiveness.
Well, it's going to be a utility. They're going to run your water, your electricity, and your groceries.
Yes. And on top of that, a lot of products that you're going to buy, especially just cups and plates and stuff like that, you don't buy from the store anymore. You have your 3D printer at home. You have a fabricator. It will just materialize in a cabinet. Oh, I need a new plate. Click a button. A few minutes later, you walk up and go like, oh, here's my new plate.
Have you read Transmetropolitan? It's a comic graphic novel series.
Oh, I haven't read that.
It has that, where it's people 3D printing pretty much everything that you would want. So
Spectre's one.
yeah.
That's what Neil Stephenson did in The Diamond Age, too.
But the convergence of things, there are things that we don't expect because there's the mixing of technology too. We can 3D print organs, organic stuff.
They fall apart though.
Well, they haven't perfected it yet.
Had a lot of trouble with it.
But you can tell that over time they will fix that. It will all be fixed.
They actually successfully used spinach leaves. They took all of the non-cellulose material out of the spinach leaf and replaced it with human cardiac tissue, and they successfully created beating heart tissue.
That is that won't be rejected by the human body because it's actual human cells, except the infrastructure or the scaffolding is from the pig.
Yeah. No, spinach.
Spinach.
Spinach leaves.
Oh, spinach.
They
Oh,
use spinach leaves.
even better.
Punch battle cells back into the
So it's very vegan. So it's a vegan transplant. Good, very good.
But it's not a non-GMO though, so I don't think they're okay with that.
Well, guess what? Twinkies are vegan too.
Yeah.
Look up the list of the ingredients. No animal products was used in except for the plastic wrapping, because those are all old dinosaurs, right?
Well, you can make plastic potatoes.
Yep.
Apple?
Yep. So getting back to the physical stuff, okay, physical devices. So we just have to look at physical states. Now we are kind of lucky because we got not only digital computers, we got binary or Boolean digital computers. Though there are only two states that we have to worry about. Okay, so with a transistor, you can say a transistor is basically a valve. Okay, so the two states that we are interested is it closed, which means it allows stuff to flow through it, or is it open, which means it is disconnected from the flow. What about partially open? It's letting 50% through. We don't have to worry about it, okay? Because we're using digital computers, binary digital computers. Things are either on or off. Is that okay? Right? So this section talks a little bit about truth, okay? Well, the only reason why we need to talk about truth is that's the kind of stuff that you learned in CISP 360. Now, how does true, false has anything to do with programming, especially in CISP 360? This is a trick question, by the way. Yep.
I was going to say it's the logic, it's the language. If you don't have a way of understanding, at least in human term, the 1 and 0, you can't program anything.
That's true. Yep, that's good.
Encoding.
But what did you learn in CISP 360 that particularly has to do with true and false?
Boolean variables?
The what?
Boolean variables.
Boolean variables. Now, Boolean variables were introduced in C++. It was not there in the original C programming language. Okay, so if you go one step back to actual C programming language, what does it use true and false in that particular language? Yes, it does. We have Boolean operators. Okay, tell me a few Boolean operators, logical operators. And, okay, that's logical and. 2 bars is
Or.
logical or. Exclamation point is logical not, negation. Yeah, that's all the stuff that you have learned in CISP 360. So as far as we are concerned, true is just one of the, well, okay, this is the tricky part. In C++ and C programming, true is defined as not false. What is false? False is 0. So anything other than 0 is true. Okay, so you might want to remember that, okay, because anything other than 0 is true. What if I have a pointer that is actually pointing to a non-null value? It is true. What if I have an integer value that is negative 5? It is true. What if I have a value that is 16? It is true. Okay, anything other than 0 is true. Okay. So now that we have talked about Boolean operators, we have talked about transistors. So now we want to see, okay, but how do these things connect? Because that's the whole purpose of this class is you learned about C, C++ programming in your previous class, and in this class, I want you to connect everything all the way down to a transistor level. Now, we are not going to design computers using transistors, okay? But we are going to at least make a connection. So what we'll do is we are going to look at several different types of transistors. This is an N transistor, so there's this description here. And then we have a P transistor. And let me see if I can display both. Yeah, I can display both at the same time. What are the differences other than the color of the transistors? The arrows. One more.
The